So for this deep dive, we're looking at a story that feels less like a prediction and more like a future history.
Right.
We've got the sources around Captain Van Kipnis's book, Storms We Chose. And the thing is, this isn't some academic model. This is from a mariner, a fisherman.
Someone who spent his entire life on the water, reading the sea, reading the sky.
And he's detailing these environmental tipping points, the choices that basically set us on a path to a flooded future.
And that's the key, isn't it? Kipnis is very clear he's not a prophet. He's just keeping a logbook. It's a straight-line projection, really, from the physics and the chemistry that were already in motion when he wrote it.
So his argument is that the details, the specifics of the collapse might be imagined.
Exactly. But the fundamentals, the physics of carbon, the chemistry of the ocean, he says those are not negotiable.
So our mission here is to pull out those insights, the moments he highlights, and really dig into his central argument that the world had clear warnings and just chose to ignore them.
Yes. And he argues the failure didn't start with some huge cataclysm.
Yeah.
It wasn't a megastorm or a tidal wave.
Yo.
It began with something slow, a visible decay of the coast he knew best, which was Florida.
Let's start right there then with that immediate, almost visceral evidence. Kipnis talks about what he called the sargassum plague. You can almost smell it when he writes about it. This wall of brown weed, 3 feet high, just stretching for miles. And the smell, he says, was this intense reek of sulfur.
And it wasn't just, a pain for tourists. It was a massive systemic warning sign. Our gas was natural, it drifts. But this became hypernourished.
This great Atlantic sargassum belt, what was fueling it?
2 things, basically. 1, rapidly warming ocean waters. And 2, just a huge load of nutrients.
Which means fertilizer.
Fertilizer, sewage runoff, everything we were pumping out from massive river systems. Think about the Amazon, the Mississippi.
Yeah.
It all ends up in the Atlantic. The sargassum just feasted on it.
And it went from being a nursery for fish.
Right, for mahi-mahi and sea turtles, into this toxic, oxygen-starved barrier. By the 2050s, he says countless beaches were just untouchable.
And that decay didn't just stay out at sea. It came right into his backyard, into Biscayne Bay.
He describes the bay's complete collapse by mid-century. It was a death by 1,000 cuts.
What were the steps? How did it happen?
Well, first you get these constant algae blooms fed by everything from lawn fertilizer to failing septic tanks. The blooms block the sunlight.
And that kills the seagrass beds.
Completely.
Okay.
And when the seagrass vanishes, you're not just losing grass, you're losing the entire foundation of that ecosystem.
So the manatees, the bonefish.
They disappeared, almost overnight. And then the sea level rise started to accelerate. And the mangroves, which are your last line of coastal defense, they just couldn't keep up. They drowned where they stood.
So for the people living in Miami, the consequences got terrifyingly practical. Their fresh water supply, the Biscayne aquifer, it started getting contaminated with salt.
And the city's solution was, well, brutal. Massive, energy-hungry desalination plants. They were literally boiling the ocean just to have enough water to drink.
And you can't talk about that without mentioning the Turkey Point nuclear plants.
No, it's this grim specter in the story. The bay water got too warm to cool the reactors, so they had to shut it down. Permanently.
Leaving tons of nuclear waste just sitting there.
Entombed in concrete, right on a flooded coastline waiting for the next big tide. It's a really powerful image of our inability to escape the consequences.
I want to pause on that for a second, because the coastal decay, you can see it, you can smell it, but then Kipnis moves to the invisible catastrophe, the one happening out in the deep ocean. He calls it the silent thief.
It's the perfect name for ocean acidification, isn't it? We all think of CO2 as a warming gas, but about a third of it gets absorbed by the ocean.
Right.
And molecule by molecule, that changes the water's chemistry. It lowers the pH, makes it more acidic. It's a thief because it steals the very building blocks of life without leaving a trace.
And it's so devastating because it hits the smallest organisms first, the ones that need carbonate to build their shells.
Precisely. Your coral reefs, they become fragile. Their skeletons start dissolving faster than they can grow. But even more critically, the plankton at the very base of the food chain, they struggle to form shells. And if they fail,
The whole system starves from the bottom
the
up.
whole system stars.
He has this one anecdote that's just haunting. A fisherman in Guatemala looking at this beautiful sapphire blue water, but there was nothing in it. The abundance was gone. And the fisherman, he couldn't tell you the pH level, but he just knew the water was different.
That's the mariner's instinct, that visceral knowledge. And that unraveling, It really showed up in the North Pacific with the blob.
What started as just a weird patch of warm water in the 2010s.
Yeah, just an anomaly. But
Yeah.
by the 2030s, it had spread and turned some of the world's richest fishing grounds into, well, a biological desert.
So what did the blob actually kill?
The heat and the acidification, they caused this catastrophic failure at the base of the food web. Phytoplankton just plummeted, and that meant the forage, fish herring, anchovies, they vanished.
Then silence.
A literal silence. Kipnis documents it. By 2040, you see rusting crab pots in Dutch Harbor. Kelp forests in California are thinning out. Sea lions and birds starving by the thousands.
There's that one quote he uses. The water looked impossibly blue, so inviting. But the fisherman knew.
That blue meant emptiness. The collapse wasn't a roar. It was a stillness.
So now we have to connect that stillness in the ocean to the planetary scale. Kipnis shifts focus to the huge global drivers, the ocean currents and the atmosphere.
He calls the Gulf Stream the ocean's heartbeat. But by the 2030s, that beat was failing. We're talking about the Atlantic Meridional Overturning Circulation, the AMOC.
Let's just quickly break that down because it's such a critical engine for the planet. Warm, salty water goes north, cools off, gets dense, and sinks.
Right, it's a giant conveyor belt driven by density. But what happens when you pour billions of gallons of cold, fresh, light water on top of it?
From the melting Greenland ice sheet.
Exactly. That fresh water messes with the density. The water can't sink anymore. So the engine, the whole conveyor belt, it just stalls.
And the effects of that stall they're really counterintuitive. It's not just things get cold.
Not at all. In Europe, yes, severe cooling. They lost the Gulf Stream's warmth. You had failed harvests, late frosts in France. But at the same time, the tropics got hotter.
Monsoons fail.
In South Asia, in
Yeah.
Africa, leading to massive water shortages. And for the U.S. East Coast, sea levels actually rose faster.
Because the water was piling up.
The current wasn't there to pull it away. It's this complex, cascading system failure. And we'd seen it happen before in the geologic record with the Younger Dryas. The warning was there.
And at the exact same time, the atmosphere was losing its stability too.
Yes, the jet stream. Kipnis calls it the river of air that steers our weather. And its power, its tension, comes from the temperature difference between the Arctic and the mid-latitudes.
But the Arctic was warming so much faster than everywhere else.
4 times faster, so that tension was lost. The jet stream slowed down, it got wobbly, and it started to stall.
And stalled weather, for people on the ground, what did that look like?
It looked like extreme weather, just parking itself for weeks on end. He paints these pictures of a farmer in Kansas watching his corn stalks turn brittle after a 40-day drought under a heat dome that just wouldn't move.
And the opposite was happening elsewhere, right?
Right. A storm would just sit over Germany for 2 weeks, dumping rain until rivers flooded catastrophically, or the polar vortex would wander south and freeze Texas for a week. It wasn't just heat. It was the instability, the chaos.
This is the moment then, the breaking of these huge planetary systems. This is where he connects the environmental failure to the societal breakdown that follows.
Absolutely. The first symptom of that was what he calls the age of storms.
And these weren't just stronger storms, they were different.
They were slower. They fed on super hot seas and they just lingered, punishing the same places for days on end. They felt less like weather and more like a siege.
And that, combined with the stalled weather patterns, led right into the hungry earth.
You had drought and heat domes wiping out the American corn belt, Russia's wheat fields. But it wasn't just drought.
It was salt.
Salt poisoning. Sea level rise pushed salt water into the great river deltas, poisoning the rice paddies in places like Bangladesh. And suddenly, global food reserves, they just vanished.
Which triggers the Great Migration.
On a scale that is it's hard to even imagine. 5 million people leaving South Florida. Tens of millions walking out of the Sahel, out of the Ganges Delta.
And the global response wasn't cooperation.
Tragically, no. It was self-preservation. Nations built walls, literal and bureaucratic. It kicked off the age of conflict. Not wars over ideology, but wars over water, over grain, over a patch of land that could still grow food.
The end result of all that chaos is what he calls the shattered order. What did that actually look like?
It meant the global supply chains just broke. The UN dissolved. The EU fractured into nationalist states hoarding resources. Technology became a relic. A cracked tablet or an old book was more reliable than an internet that needed a stable power grid.
Humanity was reduced to these fractured remnants.
Small enclaves.
Yeah.
Surviving in isolation in the few stable places left. Patagonia, the Himalayas, parts of Greenland. It was the end of a global civilization.
And this brings us to the absolute core of the book, the most devastating part. This collapse, it wasn't inevitable.
No, it was the result of choices, decisions made in a very, very narrow window of opportunity.
That window, he says, opened around 2015-2016, the moment of hope.
The Paris Agreement. There was a real global consensus. Investment in renewables was surging. It felt like we could actually bend the curve.
But then came the betrayal. Kipnis zeroes in on two specific 4-year periods, 2017 to 2020, and again from 2025 to 2028.
And he describes a deliberate, politically driven effort to dismantle environmental protections and just walk away from that consensus.
This wasn't just symbolic, was it? Gutting agencies, scrapping regulations like the Clean Power Plan. What was the critical damage done in those 8 years?
It was twofold. First, the raw emissions. Billions of tons of avoidable carbon went into the atmosphere, locking in more warming, but maybe even worse.
Loss of momentum.
Loss of momentum, loss of trust, and the dismantling of institutional knowledge. You hollow out an agency like the EPA, and you lose your ability to monitor, to enforce, to innovate for the next crisis. That was the irreversible cost.
And the atmosphere, of course, didn't wait for politics. The ice kept vanishing, the fires got bigger, the curve was locked. Kipnis marks the period from 2029 to 2035 as the point of no return.
This is when the feedback loops took over. These are the natural processes that start accelerating warming all by themselves, regardless of what humans do.
He points to the Amazon rainforest.
Flipping from a carbon sink to a carbon source. It started breathing out more CO2 than it took in.
And the other big one, the permafrost.
Yes, the thawing of the northern permafrost, releasing enormous amounts of methane, which is a super potent greenhouse gas.
Yeah.
Once those processes got going on a large scale, the system became self-propelling. Even if we'd stopped all emissions in 2035, it was too late.
And that is the final chilling conclusion. The fork in the road was visible, the science was clear, but the path to collapse was chosen for reasons, as he says, petty as profit, as short-sighted as politics.
So to boil it all down for you, the core message from Kipnis is this. The crisis wasn't defined by the speed of the storms or the fires. It was defined by the speed of the denial.
And then he takes this long view. 50,000 years into the future, the Earth recovers, of course, the forests return, the oceans rebalance. Life goes on, but humanity is gone. A blink of an eye.
And our legacy isn't art or philosophy. It's a thin, dark layer in the rock. A geological signature. Soot, plastic, radiation, and the bones of all our domesticated animals. His final point is that we mistook our cleverness for permanence. The Earth endures, patient and indifferent, he says, waiting for the next story to be written in its soil and stone.
And that image that we could just be a disposable layer in the rock should really make you think about the choices we're making right now. While the levers of control are still, for a little while longer, in our hands,